Sounds like my kind of gum.
I'd rather you didn't. There's still one or two things that are really...
I'm the world record holder in chewing gum. I'm not afraid of anything.
Yeah, right.
How is it, honey?
It's amazing. Tomato soup. I can feel it running down my throat.
Yeah, spit it out.
Young lady, I think you better.
It's changing. Roast beef with baked potato, crispy skin and butter.
Chewing, kiddo. My little girl's gonna be the first person in the world to have a chewing gum meal.
Loser.
I'm just a little concerned about the...
Blueberry pie and ice cream.
that part.
What's happening to her nose?
What kind of idiot would keep chewing? Jeez. Don't accept weird pieces of gum from people.
Violet, you're turning violet. What's happening?
Well, I told you I hadn't quite got it right, because it goes a little funny when it gets to the dessert. It's the blueberry pie that does it. I'm terribly sorry.
Mother, what's happening to me?
She's swelling up.
Like a blueberry.
When was the last time you saw a blueberry swell up? Jeez.
I've tried it on like 20 Oompa Loompas, and each one ended up as a blueberry. It's just weird.
But I can't have a blueberry as a daughter. How is she supposed to compete? You could put you in a county.
Later.
I'm so hungry. Oh my god, this hell's so big. Yeah.
You also, I hear you're hungry. I heard grunting from the other side of the woods.
I am hungry.
This won't trick up my sleeve.
Mama always taught me to accept candy from strangers.
Oh, I'm no stranger. I'm gonna be your best friend now.
I don't have any of those.
Ah! Neither do I!
Yay.
Ah, it's so great.
Anyways, I always like to eat with a view. I'm gonna head to the top of that hill. Oh god, we're almost there. Oh, that's normal.
6 hours later.
Man, I'm feeling mighty peckish. Let's break down the situation. As we know, our initial diameter is 24 inches or 2 feet. The rate of change of this diameter is held constant at 0.25 inches per second. This necessarily means that the rate of change of the radius is half that at 0.125 inches per second. The density of our subject is described by the variable p and is 3 pounds per foot cubed. Weight of our subject can be described by the relationship density multiplied by volume. What we want to find now is the time it takes to reach 486 pounds of weight, so that we can accurately flatten our victim. Weight will be described by the variable w. Weight, as we know, is density multiplied by volume. Since our subject is a sphere, we can substitute in the equation for volume of the sphere, 4/3 pi r cubed multiplied by the density, which gives us our weight. We can then substitute in the density, which is 3, and do our algebra to get that the weight is described by 4 pi r cubed. Our final weight, of course, is 486 pounds, as given before, so we can add that as our weight, which equals 4 pi r cubed. This equation, when solved, will get us the variable r at the point which the weight is 486 pounds, which is what we're looking for. Doing some algebra, 486 divided by 4 pi equals r cubed, take the cube root, and you have your final radius, which comes out to 3.38 feet. Our question now becomes this. How long does it take for the radius to reach this 3.38 feet marker? Now we know that the rate of change of the radius is 0.125 inches per second, which equates to 1/96th of a foot per second. We can find our final radius by taking our initial radius plus the rate of change over time, which will let us find the final radius after how much time. Substituting in our values, 3.38 is our final radius, 1 is our initial radius, and it's increasing at 1/96th of a foot per second, which will be described by t. Solving by subtracting the 1 and dividing by 1/96, we get our final time it takes to reach the critical weight of 228.48 seconds, or 3.808 minutes, so that this thing can roll down this hill and make this two-dimensional.